Today I want to talk to you about precautionary planetary defense. And when we're thinking about the choices that go into the decision to act, there are many that you would probably consider to be precautionary. For the purposes of this talk, there are two things that we mean when we say precautionary planetary defense, and that is restraint and active management. We're going to talk about those in turn. For showing restraint, we're going to use Apophis as a working example for a number of reasons: its size, how close it's going to come to Earth, the keyhole complexes that are within its 2029 B plane, and up until recently, the uncertainty about how accessible those keyholes were. Because of this close approach, there's also incredible interest from scientists and the general public in the asteroid. And so a question that we need to consider is what happens if everyone wants to go and visit Apophis? So multiple state actors may want to go after this high-value target, but there may also be non-state actors who want to get involved. And if you have a lot of different people going, because they each have their own idea of what is the best thing to do, there might be a deep space traffic management issue. And among the probability distribution of outcomes, we have to consider the low probability, high consequence mission failures. Now you might ask, why should non-state actors get involved? Why would they want to? What's in it for them? Well, there could be multiple reasons. They could be wanting to demonstrate technology or just generate publicity or both, just like the Tesla launch did for SpaceX. Individuals who might want to play hero, they have an idea of what is the best way to save humanity and they want to act that out. And there are many things that we just haven't thought of. New space and these actors are incredibly innovative and creative with their uses of space. And we have to be cautious about saying, oh, they have no interest in doing X, Y, or Z. Eventually, asteroid mining will also be a consideration, and that goes into the non-state actors' motivation, at least in the long term. And the commercial activity on asteroids could be a benefit or a liability for planetary defense. It really depends on how it's carried out and the degree of information sharing. And so the governance models that might go into thinking about what would work for restraint would also be applicable, at least in part, to future asteroid mining. So there's an additional motivation. So for showing restraint, let's think about a hypothetical situation in which Apophis's uncertainty still overlaps the 2051 complex, in which the 2068 keyhole resides. And so if that's the case, we can ask ourselves, should we be laissez-faire with who goes to Apophis, or should we restrict who goes to maybe one actor? And if you're thinking, okay, we should restrict it because we don't want something really bad to happen. Maybe there's a big failure with some untested spacecraft and it slams into Apophis and it creates just enough of a nudge to put in a keyhole. And we want to avoid that. So maybe just one actor goes. If we're going to restrict who goes, we need to ask who decides. Now, St. Page does develop cooperative activities, but it's advisory only. It's ultimately the launching state that has authority for granting launches. Now, provided that past levels of cooperation among states are maintained, then St. Page does provide a framework for decision making, but there are worries about how we might go forward, and we see that right now with the moon. So you have the US-led Artemis Accords, which were rejected by Russia and China are now developing their own model for utilizing the moon. And that can create tension, which could bleed over into planetary defense. What is potentially more problematic is the militarization of cislunar space. So the US has announced plans for putting military satellites in cislunar space. And DARPA has released plans for having manufacturing capabilities in orbit and on the moon. And many state actors might interpret the installation of a DARPA factory on the moon as a military installation, which would be in violation of Article 4, Paragraph 2 of the Outer Space Treaty. And then we have to consider the non-state actors who are highly capable and may be launching from states that have varying national regulation in terms of what is required for any type of deep space exploration. And they're not going to be directly involved with same page. Now, ultimately, there is a group that's in charge, the UN Security Council, and if we really wanted to restrict who might go to an asteroid, there could be a Security Council resolution. This is pretty heavy-handed. It would require some wide support within the Council, and it couldn't have any vetoes of the 5 permanent members. If you have a fractured environment for space cooperation, that could be a problem. Right now we're okay, and so a preparatory resolution could be warranted if this seems like the only path forward of having some type of understanding of state responsibilities in terms of going to asteroids for planetary defense. That takes us to the second part of precautionary planetary defense that I want to talk about, active management. So maybe you have an asteroid with a high collision probability way in the future, and you could do something now about that. That's one part of active management, but that blends also into kind of typical decision to act scenarios. A more nuanced question is if you have an asteroid in an okay spot, but you know it could be in a better spot, would you try to move it? It's the distinction between having a safe harbor versus going after the safest accessible harbor. Any port is okay in a storm, but if you have nice weather, do you choose where to go? Now, you would want to have a metric for doing this, and I don't know what that metric is. But I'll show this keyhole map, which has a lot of resonance spikes in it. Those downward resonance spikes are not keyholes. Like for example, this 2116 one. It just brings the asteroid close to Earth. Maybe you don't want that. Maybe instead you want to try to put the asteroid, in this cusp and keep it away from that for keep it away from Earth for 100 years. And then you could reevaluate it down the line. You could use a gravity tractor to pull it to that position. Now, of course, there is some conflict between restraint and active management, but arguably at least some practicing of tractoring is needed so that we can use it in an impact emergency. And a reusable gravity tractor might not be far away. SpaceX is testing its Starship, which will be a highly capable, totally reusable spacecraft. It already has plans for 5 variants, and there could be another one, the Starship PD, Planetary Defense. And if that's the case, it could really change the way we think about planetary defense. Thank you for listening.